Miss Hogan here, and I'm going to talk a little bit about some special cases that you get when solving linear equations. By now you should be using your addition property, your multiplication property, and following the general steps to get x by itself and solve most linear equations. And you may be seeing some weird answers. So I want to talk about the three cases that you could come about when you solve those equations. The first case is what happens most of the time. Okay, these are your normal ones, the ones where you get an answer. So let's work one of those first. My example is 8x plus 6 minus 2x equals minus 4x minus 14. Now our first step here would be to identify the like terms that we have on the left-hand side. There's an 8x and a minus 2x, and we want to go ahead and put those together. So 8 minus 2 would become 6x plus the 6 equals negative 4x minus 14. Since there's no like terms left or like terms right, our next step is to start moving terms from one side to the other. We want to get our x terms together. So I'm going to move negative 4x by adding 4x to both sides. Negative 4x plus 4x goes away. But over here, 6 plus 4x becomes 10x plus 6 equals negative 14 left on the right. My next step would be to move this 6 to be with the negative 14. When you cross 0, you've got to use that opposite sign to cancel it out. So negative 6 plus 6 negative 6 goes away. That leaves us with 10x equals negative 14 and negative 6 is negative 20. I'm almost done. Last step, to get x by itself, we're going to divide by 10. That removes the coefficient of 10 off of x. 10 divided by 10 becomes a 1, and 1x is equal to our answer, negative 20 divided by 10, which is negative 2. Now notice here, we got an answer. So we have a solution. We can check that solution by plugging negative 2 in on both sides, and you'll get a true statement. But negative 2 is the only solution for this problem. So we say that there is just one solution. And this happens most of the time when you get x equals to some number. So what about those ones that I said were the special cases? Well, they're going to look the same at the start, but when you start working on them, something different happens. So let's go ahead and move on to one of those examples. I'm going to erase here. Come all the way up to our original question, and let's make it number 2. For this equation, we're going to solve negative 8x plus 5 equals negative 2x plus 14 minus 6x. Now, like I said, looks pretty similar to our first example. We're going to even start with the same step. No like terms here, but on the right, we've got negative 2x and negative 6x. So let's put those together. That's going to be negative 8x plus 14 when we bring that down. We have negative 8x plus 5 on the left. Our next step is to get our x terms together. So we've got negative 8x here. If I want to move it over to the left-hand side, I'm going to add 8x to both sides. But what happens when you have a negative 8x and you add 8x? They completely go away. 0, nothing. All that leaves me with is a 5 on the left and a 14 on the right. Read that. 5 equals 14. Can that be true? No. That's a false statement. Doesn't work. 5 is not equal to 14. It never is. And there's no x left for us to solve for. So we have to be done. What this tells us is that this equation is false. It's a contradiction, sometimes called inconsistent, but it led to a false statement. And if you get that, there is no solution. And that's the first of our special cases. It didn't work out, but it does give us an answer. And our answer is nothing. Nothing works here. There is not a number that I can plug in on this side and that side to get a true statement. So we've got those cases that come with one answer, and now we have those cases that have 0 answers. What is the last case? So let's erase here and do one more example that's going to look similar to these first two. We'll call it example 3. Here's your equation. 2 minus 8x plus 3 equals 5 minus 8x. Starting off by combining my like terms. On the left-hand side, this time we've got our constants 2 and 3 that need to go together. Notice that minus is attached to the 8x. So this is just 2 plus 3, which would give 5. Bring down my minus 8x equals 5 minus 8x on the right. Now what you might see here is something I like to call identical sides. If you ever get identical sides, meaning same numbers, same signs, same x terms on the left and the right, then you know it's going to lead to this last case. If we continue to solve by moving this 8x or adding it to both sides, negative 8x plus 8x, negative 8x plus 8x, they go away, just like before. Different result though. We're left with 5 equals 5. Is that false? I think so. That's true. 5 is 5. So that's what we call a true statement. But you still can't solve it any further. There's no x. So for that we have to be done, but since we get a true statement here, we're going to say that there are infinite solutions to this problem. And what that means is that no matter what number you choose, if you plug it in on the left and on the right, it gives a true statement. It works. So it checks. And there's way too many for us to just check every single number because they all work. So that is our third and final case. And it's the second of our special cases. So when you're solving linear equations, watch out for those that get an answer. That's most of them. They work out. But there's 2 special cases that don't. Some, false statements, means no solutions. And others where it gives a true statement, and that means infinite solutions. I hope that helps.